Here to reveal a plan for a trip around the moon is the chief of the guided missile development at the United States Army's Redstone Arsenal, Dr. Wernher von Braun.
A voyage around the moon must be made in two phases. A rocket ship taking off from the Earth's surface will use almost all the fuel it can carry just to attain a speed great enough to balance the pull of gravity. Unpowered, it will then keep circling the Earth in an orbit outside of the atmosphere. This is the first phase. However, if we can refuel the ship in this orbit with fuel brought up by cargo rocket ships, it can set out on the second phase, the trip around the moon and back. To facilitate this refueling operation, we will establish an advanced base in the orbit, 1,000 miles above the Earth. This advanced base, or space station, will be headquarters for the final ascent to the moon. Our space satellite will have the shape of a wheel, measuring 200 feet across. Its outside rim will contain living and working quarters for a crew of 50 men. Just below the radio and radar antenna is the atomic reactor. Its heat will be used to drive a turbo generator, which supplies the station with electricity. Access to the station will be through an airlock in the hub. The three large spokes are elevator shafts, and the small pipes are used as condensers for the turbo generator and the air conditioning plant. The entire wheel will slowly rotate at 3 revolutions per minute. The resulting centrifugal force will produce an artificial gravity for the men in the rim. Notice that the floors are placed so that the men stand with their heads towards the hub. The wheel is divided into 9 sections. The first section is headquarters and communications. The next section will be for Earth weather observation and prediction. Military reconnaissance experts, aided by powerful optical and radar telescopes, will observe every point on the globe as the space station makes its complete trip around the Earth every 2 hours. Next is the emergency hospital section. And then the astronomy division, where men will keep an eye on the rocket ship as it makes its trip around the moon. The rest of the space station will house calculating machines, maintenance facilities, air conditioning equipment, living quarters, and even a botanical and zoological laboratory. This entire space station will have to be prefabricated and tested on the ground. After dismantling, it will be transported in pieces up to the orbit. For the difficult job of reassembling the structure, we have provided a new type of spacesuit. Using gyros and 2 small rocket motors, the operator can tilt and move in any direction. Located outside will be 7 remotely controlled mechanical arms, each a specialized tool. By rotating himself within the spacesuit, the operator can use any of the arms for the variety of tasks in assembling the space station. When the day arrives for construction to begin, the thousands of parts for the space station will be transported to the orbit by our multi-stage rockets. We merely replace the wing passenger section with a simple cargo-carrying nose. These cargo ships will be unmanned. A passenger rocket, 1,075 miles above the Earth, will guide each of the 12 approaching cargo rockets to their rendezvous in the orbit. This ship, which circles the Earth every 2 hours, will be the command post until after the space station is finished. On the ground, the first of the cargo rockets is ready for takeoff. When the guide ship reaches the correct position in the orbit, the cargo rocket is fired. While its motors are firing, the cargo rocket is controlled by an automatic pilot, like a guided missile. Up in space, the blast-off is observed with the aid of optical instruments. In the guide ship, the navigator locks his tracking radar on the rising cargo rocket. At about 24 miles altitude, the first stage breaks away and the second stage motors fire. 2 minutes later, the cargo head blasts away from the second stage. and continues firing until its speed reaches 18,468 miles per hour. Automatically, the motor cuts off. Now, with the aid of remote controls, the navigator rotates the rising cargo rocket so that when it arrives later in the orbit, it will line up with the guide ship. Here, at 1,075 miles up, follows the most precise maneuver of the entire operation. The motor of the cargo rocket is fired again until its speed and course exactly match that of the guide ship. Radar remote control will enable this maneuver to be performed with a high degree of accuracy. 56 minutes have now elapsed since takeoff. The cargo ship is floating in space, 2,000 feet ahead of the guide ship. 2 crew members make their way to the cargo head to begin the unloading operation. First, the motor and tanks are detached. Then, 2 bottle-type construction suits are removed from the hull. When fitted in the airlock, each of these construction suits will receive an operator. The sections of the cargo ship are moved back to make way for other supply rockets soon to arrive. Construction of the space wheel now begins. The sides of the cargo nose are mechanically separated. Built-in tanks of compressed air inflate this large plastic inner section of the hub. Thin metal plates are immediately clamped on the outside to protect it from meteors. The first workday in space draws to a close. Every 24 hours, another cargo rocket will arrive in the orbit. When the airlock is attached, the pressurized hub section can be used as temporary quarters for eating and sleeping. Each succeeding load is carefully scheduled so that the parts of the station can be assembled in correct order. Nylon ropes prevent the parts from slowly drifting away. Next, the atomic reactor is installed. The wheel begins to take shape now as the 3 main spokes and rim sections are joined together. Condenser pipes are fitted next so that the atomic reactor may be put in operation. Even though there's no apparent motion, everything in the orbit is hurtling around the Earth at 16,000 miles per hour. The shell of the station is completed. Now comes the delicate task of installing instruments and the multitude of equipment inside. Finally, 2 small rocket motors on the rim, blasting for a few seconds, will set the wheel in permanent motion to revolve 3 times a minute. As life on the station settles down to routine, the large reflecting telescopes will begin their work. These giant eyes relay pictures to television screens inside the station. One telescope photographs the surface of the Earth. Another keeps a constant watch on the Earth's weather, while the third is trained on our next objective, the Moon. The primary purpose of the first moon trip will be to test the methods and equipment to be used on later voyages into deep space. It will be essentially a scouting trip around the moon, and no landing will be attempted. To understand the plan of the trip, let us use this model. Here is the Earth with the moon circling around it. Since the first half of the trip will take 5 days, we must aim the ship well ahead of the moon so that they both arrive at about the same point in space at the same time. Here we have a scale drawing of the Earth with the moon 240,000 miles away. This is the elliptical path which our rocket ship will follow, going out and coming back. For the rocket to leave the orbit of the space station, its speed will have to be increased by firing the rocket for a brief period of 10 minutes. The ship will then coast for 5 days. The Earth's gravity begins to slow the rocket down until 121 hours later, at a point within 60 miles of the moon's surface, it will begin to fall back toward the Earth. Gradually picking up speed, it will take another 5 days to coast back to the space station. This model will show you how our future moon rocket ship might be designed. It will be 53 feet in length, has no wings or tail surfaces, because it will be assembled and operated only in the vacuum of space. For the hull of the ship, we are adapting the cabin section of one of the Earth to Space Station passenger rockets. To the nose, we have added a small atomic reactor, which will drive a steam turbine and furnish electricity for the ship's instruments. This shield will protect the crew members from dangerous radiation. The ship's crew of 4 men will be placed 2 in the front and 2 back here. This is the directional radio radar antenna. Located underneath is the airlock for a spacesuit. The suit can be entered from inside the ship. Clustered around the rear of the ship are the 7 extra fuel tanks filled with hydrazine and nitric acid. All but the centrally located tank will be released when empty near the end of the return trip to cut down on dead weight. Even though we now have the theoretical knowledge to make a trip to the moon, it will be many years yet before our plans can fully materialize. However, let us imagine for a moment that the many problems have been solved and that after completing our space station, we are ready to begin our first voyage around the moon.
Ladies and gentlemen, through a worldwide network of radio and television, we are bringing you an on-the-spot account of the first expedition around the moon. Here at Space Station number 1, 1,000 miles above the Earth, the final preparations have all been made. Except for the time the rocket is on the other side of the moon, our radio and that of the station will be in constant communication with the ship during the 10-day voyage. As the moon ship stands by, the all-important pressurized spacesuit enters the rocket's airlock for the last time. During the trip, it'll be used only in the case of emergency. The captain is the last man to come aboard. He will direct the entire expedition from his position at the front of the ship. The navigator, with his specialized instruments, is responsible for plotting the unmarked path through space. The radio operator must maintain constant communication with the Earth and the space station. Finally, the rocket ship's motor and other mechanical functions will be the responsibility of the engineer. After final instrument check, the ship's crew lock themselves in position for the blastoff. Now, only minutes remain until firing time. The captain sets the automatic firing timer and reports to the space station.
RM1 to Station 1, firing timer is engaged. We will begin power maneuver for departure in exactly 16 hours, 23 minutes, 47 seconds.
Roger, RM1, 16 hours, 23 minutes, 47 seconds, over.
Crew will secure and stand by for firing in 84 seconds. Acknowledge. Navigator, check. Radio okay. Engineer, check. Form 27-1 report. Over. Engineer to Captain. Motor pressure 447 psi, 3 low. Turbo pump 11,000 RPM, right on the button. Actuators steady. Guidance readings okay. Cabin pressure 0.3 psi low. Cabin temperature 72 degrees. Over.
This is Station 1 calling RM1. Our radar telescopes have charted your firing time and course. Give us a voice report for instrument error check. Over.
Well, we're on our way. Joe, how about another report?
Our firing time was 10 minutes, 0.35 seconds. Cutoff velocity, 21,888 miles per hour. Cutoff altitude, 1,765.2 miles. 1.6 low.
Okay. Now let's double check that star tracker with an optical and radar fix.
Right.
Captain, position check shows 0.7 miles below, 1.2 miles left, and 0.3 miles ahead of standard flight path. We have only a 0.03% error in azimuth reading.
Sounds good. Bill, let's transmit all your tape reports to the station.
Gentlemen, we are interrupting our program to give you the following message. Moonship RM1, which left the space station a little over 51 hours ago, reports a distance of 169,000 miles from the Earth. The ship is traveling at 9,400 miles per hour, and deviations from the intended flight path have been so small that the captain reports no corrective power maneuver has been necessary as yet. We are happy to report all the crew are in good condition.
Check the console, Joe. Try to pick it up. Bill, is your electrical system working?
Emergency condition. Repeat. Verify. Over.
Meteor hit, number 2 nitric acid tank. Pressure's dropping fast.
It's number 2, all right. Joe, put the air blowers on emergency power. Frank, get in the bottle suit and patch that hole. Don't use your motors near that leak. Try to reach it with the gripping arms.
Station 1 to RM1. Station 1 to RM1. Our instruments indicate emergency condition. Verify. Repeat. Verify. Over.
RM1 calling Station 1.
This is Station 1. Go ahead.
At 51 hours, 22 minutes elapsed flight time, registered hit by a small meteor. Puncture between Station 51 and 52, upper bulkhead of nitric acid tank number 2. Repairs are underway. RM1 to Station 1.
This is Station 1. Go ahead.
Meteor puncture sealed. Estimated diameter of meteor 1/16 of an inch. No injuries, equipment okay. Estimated loss 180 gallons of nitric acid. Proceeding on flight plan. Over and out. Station 1, this is RM1. At 110 hours, we are beginning measurements at rim of the moon for accurate position fixes. We are now picking up the unknown side of the moon. Bill, give me an altitude reading.
Okay. Radio altimeter reads 22,886 miles from the moon's surface.
Oh, we're moving in fast. Frank, have you got anything in that star occultation reading yet?
Just a moment, I'll run it through the computer. Captain, we're approaching the moon on ellipse 29. Course indicates collision with moon at 1:20 hours, 56 minutes. Correction tape 340 must be used at 1:16 hours.
As the 116th hour approaches, the navigator must act quickly to avoid a collision with the moon. He starts the tape selector, which will automatically correct the rocket's course by firing the motors for a precise number of seconds.
RM1 to Station 1. At 116 hours, conducting power maneuver on correction tape 340. Out.
Captain, we're almost on the button. We'll pass the moon surface at 63 miles instead of 60.
Close enough. We'll make the correction on our return maneuver. Joel, set the spatial attitude control to keep us lined up with the flight path tangent. Stand by for observation schedule 17.
Station 1 to RM1. We acknowledge observation schedule 17. Checklist as follows. Green filter 93-B on electronic camera on upper astrodome. Use magnetic color tape on station 3, lower astrodome. Run 180-degree graph through contour mapper, over.
The next few hours will constitute the most important phase of the trip. The moon is sweeping past the ship at great speed, and in the brief span of about 3 hours, all close-up observations of its unknown surface must be completed.
RM1 to Station 1. We are now seeing the Earth disappear behind the moon's rim. This will be our last radio message until you see us on the other side.
Roger, RM1. Good luck.
I see what looks like a tremendous crater ahead. Bill, what does the contour mapper indicate?
Depth of crater is beyond range of contour mapper.
We'll reach the day and night terminator in 5 minutes. Frank, arm your flares and stand by to fire when I give the signal. Okay, Frank. Fire your flares at 3-minute intervals.
Captain, I'm getting a high Geiger count of 33 degrees.
My scintillation counter indicates a high degree of radioactivity on the same bearing.
Contour mapper shows a very unusual formation at about 15 degrees southern latitude and meridian 210.
Get some flares in that area, quick. RM1 to Station 1. Do you read us? Over.
Roger, RM1. We read you weak but clear. Over.
At 123 hours, we are observing the Earth emerging from behind the moon. We will leave moon shadow at 124 hours, 14 minutes. Our ETA in orbit is 241 hours, 27 minutes.
After 3 hours of total darkness, the ship breaks from the moon shadow into the glaring sunlight to continue on its 5-day return trip. The irresistible power of the Earth's gravity has now changed the rocket's direction and is pulling it with ever-increasing speed back to the space station.
Frank, start the gyro attitude control for the braking maneuver and give me a time set for firing.
Check.
At 240 hours, preparations are being made to enter the orbit of the space station. The ship's direction is reversed so that the subsequent firing will slow the rocket's speed and jettison the empty fuel tanks.
Okay for firing. Guidance tape 264 inserted. Set firing timer for 241 hours, 49 minutes, 11 seconds.
Okay. Joe, set the tank release and report.
Fuel tank set for release.
Firing timer set. Stand by for power maneuver in 3-5 seconds.
Ladies and gentlemen, you have just witnessed the first successful voyage into interplanetary space. This pioneer trip around the moon will soon be followed by an expedition which will actually land on the moon's surface. Even now, construction is going forward on the atomic-powered rocket ship that will challenge the limitless depths of space and solve the mystery of the red planet Mars.